Hello, everyone. This is Levent Gürdemir, UTA Planetarium Director. Planetarium remains closed, but we are continuing our weekly star talks with you. And last week we did it on Thursday, and this week we are doing it on Tuesday. And starting this week, every Tuesday, our live star talks or public shows will continue. So I would like to little bit mention about our setup here. I am currently alone in my office, but to make this live stream possible, there is Jim Bader, our program coordinator. Jim is currently at his home. There is a mission control center he set up, and who is doing a lot of computer controlling to make this live stream available. Also with us are planetarium educators, Jennifer and Huzara, helping with the comments. By the way, don't forget, you can participate in these live streams by adding comments to your chat window. So drop your question, and we will, at the end, get back and go through your questions and answer them. So let's start. On our screen currently, we are looking at our southern sky from Texas, 9 p.m. So I hope it is going to be a great night tonight. Well, the forecast is showing otherwise, but let's not worry about that. If we have a clear sky view, one thing you will notice is there are some planets you can see in the night sky. But rather than doing like a traditional planetarium stargazing, we will try to actually use our powerful planetarium system and go visit each planet. So the first planet, guess which planet should be first to visit? Well, we need to leave Earth. So let's leave Earth now. We can look at our beautiful planet from the astronaut's view, like when they're in space shuttle, when they take off, going to the orbit, they turn and look at this planet, and we will try to replicate the same feeling. We will look at our planet from little distance. So then we will navigate our spaceship, and the first planet we will venture is going to be Mercury, because the Mercury is the closest planet to the Sun. And it's pretty small. How would you feel if we were living on Mercury? So I think it wouldn't be the nice thing or nice idea to live on the Mercury. Well, we are still taking little time over to go and approach the Mercury. Now we started moving. Well, the distances are great. Do you remember how do we call the distance between Earth and the Sun? Well, we don't want to talk about miles and kilometers and even feet here, because those are too big numbers in the astronomical scale. When we are talking about distances in the solar system, we use the unit called AU, stands for Astronomical Units. And one astronomical unit is the distance between the Sun and Earth. So here is Mercury. We are now around Mercury with even the latest technology. It is not possible to go near Mercury that fast. So this is only available and possible at UTA Planetarium. So here is Mercury. We said Mercury is the closest planet to the Sun. It is slightly larger than our moon. If it was around Earth and orbiting around Earth, it could be just like the moon of Earth. So the Mercury doesn't have air. Because there is no air, it's not a good place to choose to live. I wouldn't buy any real estate on Mercury, because I cannot breathe on the surface of Mercury. Because there is no air on Mercury, one side is cold and one side is pretty hot. Because what air does to a planet is actually providing a uniform heat distribution. So one side, another side doesn't get too much difference in terms of temperatures. Yes, on Earth, the days are hotter, relatively hotter than nights, but the difference is too tiny comparing to these planets without any air. All right. Mercury is not very interesting planet because of all the items we thought. I would like to go ahead and move to the second here. It's Venus. Well, is little different than Mercury. Venus, with like the size-wise, it is pretty much like Earth, but there are big differences. We cannot say Earth is Venus is like Earth. The main difference is life conditions are not great on Venus surface. When we look at Venus, it is always cloudy, covered by thick clouds. And Venus have air. But the air is different than Earth. It is not like the oxygen and nitrogen, just like our Earth. The Venus's air is a very dangerous chemical gas abundancy. It's called carbon dioxide. So if we breathe carbon dioxide too much, we would die. And on Venus, this carbon dioxide not only makes the life impossible, but also heats up the planet. Because carbon dioxide is considered a greenhouse gas, a gas that tends to trap a lot of heat from sunlight. So when sunlight reaches the thick clouds of Venus, it is being trapped in the clouds and warming up the planet. And it is reaching, the surface temperatures are reaching pretty high, about 900 degrees on the surface of Venus. Whenever I say Venus is too hot, I'm not talking about like the summer Texas hot. It is definitely much hotter than that. By that, the temperature on the Venus surface is exceeding the Mercury. Even though it is not closest planet to the sun, it is the hottest place in the solar system. So let's, if we didn't have cloud coverage, for example, we had some spacecrafts arrived on the surface of Venus. Not recently, even they were back in the 80s and 70s even. There were some unmanned missions, robotic missions to the surface of Venus, and some of them had successful landings and gave us an idea what the conditions are on the surface. So if we didn't have cloud coverage or air on Venus, Venus would look like this. Pretty much looks like a desert. And there's a lot of volcanic activity on Venus too, because of all the internal planet temperatures are being so high too. One other thing about Venus is Venus spins very slowly. So it is slower than Earth. On Earth, one spin, we call it 24 hours a day. It is much longer on the surface of Venus. And also it spins backwards. So all the planets have a counterwise rotation. That's coming from all the beginning of the solar system. It was just the lower momentum, lower energy spin direction. But that's not the case for Venus. Venus spins in the opposite direction slowly. And the only way we can explain is perhaps an earlier collision with another object in the solar system that caused Venus to rotate in the opposite direction, which is possible. So, after Earth, which planet comes next? I think Earth. Earth is my favorite planet. Do you know why? Because Earth is the planet I live in. Now, hopefully, everybody watching this stream is from Earth. We may need to say hi if there are some other people watching us from different planets too. So, Earth is my favorite. I can breathe easily on Earth, and I can do all of my activities on Earth. Earth is a great home for us, and Earth has a lot of living species. Let's take a look at Earth from orbit, as we usually don't see it like that, right? When we look around, Earth may be different, but this is our nice and blue home, our beautiful planet. We just passed Earth Day, but we need to consider protecting our Earth when we are doing daily activities. So please be respectful for our planet, to our planet, and protect it as much as possible from here. So it's not just like we shouldn't do that only Earth Day, we should do it year round. All right, so which planet would you like to see next? I think I can hear Mars. So Mars is a small planet. It is about half size of Earth. Now, there are quite some number of movies around about Mars. We are in the future moving to Mars, establishing colonies on Mars, even invading Mars. Is that possible? Well, maybe in the past. Maybe conditions were better in the past on Mars, but the conditions right now are pretty tough. Well, Mars is a small planet, and that small planet apparently lost its water. Well, we have a great evidence that Mars surface had water in the past. Well, because the rovers, all the robotic missions we sent to Mars, did a great exploration on the surface and found a lot of evidence, like some rocks were worn out, and they worn out that way only on the riverbeds on Earth. So that gives us some clues, and also there were some further clues too. So then what happened to water? Well, water apparently on the surface water apparently evaporated. And the reason is Mars has very thin atmosphere, and because Mars is smaller than Earth, its gravity is less than Earth. To hold water on surface, so water actually tends to escape to the space. If we think about on our Earth, what keeps the water on the surface is two things: gravity and air pressure. Because water with the sunlight tends to evaporate, and this evaporation doesn't reach out to space, and it is at one point the air pressure stops the evaporation, and they form clouds, and it falls, and when it cools down, the water falls back to ground as rain. So that is not likely to happen on Mars. So when the sunlight evaporates the water, so evaporation, or the water vapor is goes into space, leaves the planet and doesn't come back. So you need gravity, and you need little air pressure to hold water in the liquid form on the surface. With that said, the surface is just a dry desert, and it is the living conditions are pretty tough. The Mars is very cold because it's thin atmosphere, and the breathing is not possible, at least for us. The humans cannot breathe. How about under surface? So under surface, there's not a lot of volcanic activity on Mars surface because probably it has a smaller gravity. There is not much under surface activity going on, but there's still some. But the latest evidence shows us that there may be underground water on the surface of Mars. Well, there are also icy polar caps on Mars, which makes it very interesting. We see those type of ice activity on the poles of Earth too. So after Mars, we don't want to go to the Jupiter because I think we would like to give a break here and continue our outer solar system journey next week. But behind the Mars and Jupiter, so when we look at the planets in the solar system, and if we can just look at maybe the orbits, you will see a nice separation. They are not equal, but Mercury, Venus, Earth, and Mars are nicely separated from each other. But something's going on between Mars and Jupiter. There's a big gap. It looks like there was another planet, but that was just gone missing. So what is located between Mars and Jupiter is actually a big real estate of shattered rock. We call this Asteroid Belt. So there are hundreds of thousands of asteroids just orbiting in the band form on that region. So it is likely possible that sometime in the way past in the solar system, there was maybe an actual planet forming or residing in that region, and after a collision, which happens a lot in the early solar systems, star systems, that planet shattered into pieces, and what happens after collision is all the shattered particles continues to orbit in the same direction. So this is probably what happened, we think, that created this asteroid belt. The properties of asteroids are they are very small and their shape is very irregular. Some of them are in the shape of potato. Some of them are nearly round but not perfect. And even some of them are like elongated pencil-shaped asteroids. So this is called the asteroid belt. And a lot of what we call shooting stars in the sky is actually coming from that region. Because these particles, small particles, and some of them can be like a size of pebbles and even dusts, but some of them may be as large as maybe the size of a ball. When they get close to Earth, they may be attracted by Earth's gravity and even Mars first, and then they may be pulled onto Earth, and finally they collide with Earth. Yeah. Collision is not likely for a small object with Earth because there's something around Earth here, which is pretty thick layer, and this air tends to burn because these particles are moving in space. It may look like slow in our simulation, but they are actually pretty fast. They're faster than anything we know on Earth. and they go into the Earth's air at high speed. And air doesn't like fast-moving objects. This is why we design aerodynamic airplanes and even cars, right? Because to get more fuel efficiency and to make the motion better and with less friction, less energy, uh, we designed these things with the aerodynamism in mind. But for asteroids, the air burns them, and we see them as shooting in the stars, shooting stars. So uh, let's look at some of the uh, questions. You can always drop your question to the chat window, and we'll get them answered as much as we can. And then, since we talked about asteroids, we will go to the Sirius, one of the most famous asteroid we know of. And uh, it takes a while to get from some point to another point. Even we can do it pretty fast in the planetarium. But keep in mind that designing a space mission takes a decade or so. And depending on where you are going, after you launch your rocket, it may take years to reach your destination. So here is Ceres, one of the asteroids, big asteroids in the asteroid belt. And we can visit Vesta if you like. While we are waiting on our questions, let's go visit Vesta too. And to visit an object, you can always come to the planetarium after we open, or just tell us during these live sessions that which destination you would like to see, and we can take you to that destination without any problem. So as you can see, Vesta, its shape is very irregular, and it's a potato-shaped asteroid with a lot of craters on it. Craters are great indicators for impacts by some even smaller asteroids. Because this region is pretty dense and crowded by asteroids, there are a lot of collisions. All right, so next, asteroids different than comets and Pluto. Yes, why not? Well, we were saving it for other solar system, but yes, certainly we can go to Pluto. So we need to drive our system a little hard to go to Pluto because it is at the end of the solar system. So Pluto, uh, we don't call it a planet anymore. Uh, and the reason for that is, and it is still, if somebody tells me they believe that Pluto should be considered a planet, I am not going to argue with them because planet is a very loose definition. There are a lot of planets that have different characteristics that it is very difficult to find a common definition. Uh, so right now we are looking at the Earth shape on Pluto. Well, Pluto. This was discovered after the recent, slightly recent mission. So Pluto has a. This is like perspective though, a heart-shaped feature on it, but it is. If you look at from different perspective, it is not heart. So this is just a perspective illusion. Uh, Pluto is what we think mainly ice, or has a lot of ice uh, in its body. So if we bring that Pluto into a closer region in the solar system, Pluto will start melting, and it will actually turn into a comet. So this is one of the reasons they decided maybe it's not considered a planet. And Pluto has great features on it with the space missions like this. You can see all the ice mountains we can spot. Again, these type of detailed surface images wouldn't be possible without space missions, because when I started my career, Pluto didn't get to visit by a NASA spacecraft, and all we got was the picture from Hubble Space Telescope, and that image was very fuzzy. It not anything about Pluto. It would be even shame to show anybody to say this image is from Hubble Space Telescope, because anybody would expect a better planet image from a space telescope. But Pluto is small. It's even smaller than our moon. Uh, and it orbits a little differently. The orbital tilt is greater than other solar system planets. So there was a big debate that whether Pluto was in the solar system at the beginning or maybe captured afterwards. But doesn't matter. Pluto, we still love that planet. Yeah. Another question is, between light pollution and WX, any hope of our being able to view asteroids 52768, 1998 OR2 in the next few nights? It is not likely, because it is going to be it's a tiny asteroid, and the far away will make it very difficult to spot. But this morning I have seen some pictures released by NASA, apparently with the some Earth-based telescopes it is spotted, but again, those telescopes are pretty large. So one other question I see: how often does the ISS have to avoid debris in space? Now that's a very big problem for anything in space. Uh, because the debris, the space debris, some of them are like the dust particles. Dust particles are not a problem on Earth, but when they are at high speed, they can actually make very big impacts. And we've seen in the past that they knocked down some communication satellites and damaged them very badly. So for astronauts, it becomes a big problem. There are, to my knowledge, some radar system, Earth-based, tracking this space debris, and certainly ISS's main one of the main tasks is avoid them, but uh, not actually. You cannot just steer ISS to avoid the debris. So ISS is completely uh, on orbit, moving with the laws of physics, uh, and they do occasionally to. ISS to avoid some of the troubles. All right. 1:30 is showing my time, and thank you for coming to our live stream. And if you have further questions, you can still use the chat window to drop your comments or connect us by other ways, Facebook, other social media. And we'll try to answer your questions. Otherwise, just come back next Tuesday because talk about the other planets. And in the meantime, we'll put more and more weekly sky videos. So don't forget to watch them. They are great. And we'd like to thank to you for watching, and also thank you to the planetarium team, Jim Bader, our program coordinator, Jennifer and Huzara, our great presenters. All right, bye.